Round of working on our Stormlight project. Butch is here with me tonight, and last week we finished up the listening function that you see on the screen right here. And this week we'd like to actually use that listen function to control the state of the light. So we're going to implement a crude little state machine tonight, and I think we need to start by making sure or seeing where we're going to wire this into the code. So, Butch, you weren't here for this, but I created a hardware.c file. All of the hardware specific functions got moved over there.
Awesome. Do we have a live share link for this one?
Yeah, I bet that would be nice, wouldn't it? All right, folks. It's been so long since I've gotten to play with others that I forget how to do live share. So we're going to start our collaboration session, and we're going to sign in with GitHub. All right, and I'm doing a little two-factor authentication thing here, so I'm glad I remembered to bring my phone down here with me. All right, looks like we're starting a collaboration session. That's always very promising. And we will share our terminal so that Butch can actually type in here too. And Butch, here comes the link. All right, so let's do just a quick little walk through what we've got here again. So we've moved the hardware related functions out to their own header and their own source file. Here they have their own test as well, so that we don't need to mock out, or we don't have to have a weird mixture of mock and not mock tests in the same file. And the result is that we have two separate tests. We have test hardware, which tests just the hardware functions. And we have test Stormlight, which tests the core functions. So we have things like testing the lightning. We've got what's called the LED test. We really aren't testing the LEDs in there anymore. We may rename that at some point, but maybe that's not for tonight. I feel like we probably also want to, I need to take a quick look in here into the CMake. Okay, we manually called out the files. So I almost want a separate test around the logic for the main program loop. Does that seem like a reasonable place to start here?
Sounds like a good place to start.
All right. So we're going to add test loop.c, and now we need to actually go add the file so that this doesn't get cranky with us. All right, and in test loop, we've got stuff we need to pull out of. I'm going to close down all these hardware tabs here. They don't seem like they're that helpful to us. But test LED is going to have all kinds of fun stuff up here at the top that I don't want to think about. I think we can pull those out of here, but I don't feel comfortable doing that just yet. We'll look at that at a cleanup round maybe. But we do definitely have a bunch of fake functions that we want. We need all this stuff up here. We need that for sure. So let's put that there. And we definitely need to define the FFF globals, or we're not going to have a good day with our mocking. Not 100% certain we need to do any mocking out of this one. This is my only my only concern. I'm not going to bring those mocks over.
Bring them over if you find you need them, right?
Yeah. Test group. Loop. And it's test setup loop. And I also need a test teardown loop. And oh, I need a test group runner. And I've been doing a lot of playing with G-Test last couple of weeks, and so my brain's not in Unity space.
Well, I have again had a couple of weeks of almost no code written, so
Ah, geez.
I'm in any code space right now.
I have to say my last week and a half has not been any code written. I'm in a requirements gathering phase for sort of a white label, say a project like this, but maybe with a little bit more enterprise level documentation and traceability around it.
I've been in more of a guide and coach phase for the past couple of weeks of monitoring a couple projects that are going on, and while that's going on, getting ready to start another project, which will definitely be almost all coaching.
Well, that could be. What you're saying is this project will suddenly become very important for your sanity or something like this.
Yeah, exactly.
All right. Okay, so we need. I don't know if we need it to do anything. Oh, test main needs to know about this test. It needs to run test group. Loop. And let me see. All right. We also, yeah, that's good. I don't think I need to do anything else in there, so let's just save that. This is probably actually a really great time to do a CMake.
Make sure the basics work, right?
Yeah, well, more importantly, to just find the test loop. But it's not a terrible idea there. Make sure we didn't break everything. Our tests are good. All right. And here's a change from last week that you didn't see, but anybody who watched last week's will recognize it. We're using C-test, and it gives us this nice display for our two different test executables.
Nice.
So unfortunately, those don't give us good breakdown of what might have failed in a particular one. So I want to...
C-test have any options that you could configure it with that would get more verbose output from it?
There is. I'm not super happy with it. I didn't remember it right. There's definitely something there's a verbose type build. I don't remember what it is off the top of my head, but we've used it before. It's not going to show anything because nothing failed. If I made a test fail, it would show it.
Okay.
We were using that in our CI/CD pipeline so we could get the nice C-test output, but then if something failed, it would show it. All right. I want to know the name of our actual executable, so it's test_Stormlight. Oops. There, it's like that. Okay. So when we run our red-green refactor cycle, we can see our failed test that way. Okay, and now I think we need to go back into the... Sorry, what's that?
Always makes it easier.
It does. Okay, so here is our lightning function, or here's our loop function in Stormlight.c, so we can safely call that, I think. So over here in test loop, what do we want to test first, Butch? Maybe I'll let you drive for a minute. Let's talk about what we should test first.
So does it already have some behavior?
So the minimum behavior that it has right now, probably that behavior should come out, is it just calls the lightning function constantly.
Okay.
And I feel like that's not.
What kind of behavior do we want it to have? So
Yeah.
we test into it.
So I think early on in the project we talked about what this was going to do, but I think anybody who's been following along for 6 episodes now, about 2 months ago, might have forgot. So I think what we decided was normally the lights are off, and when a loud enough noise comes in, when the listen function returns a value over a certain threshold, it should run a lightning cycle.
Okay.
And the thought is run one lightning cycle and then exit, and then go back to being off and waiting. So this is where like one of those nice state graphs would have been really helpful, but
Yeah. So we need to test that loop is actually calling listening, and we need
Yep.
to test that it does those particular behaviors when listen returns particular values.
yeah.
Okay. So the start of that is making sure it actually calls listen, right?
Yep, I do think that seems reasonable. I'm going to go ahead and let you take the wheel and let me follow you.
Okay.
I think anybody who's been following this has had to watch me type enough for the last couple of weeks.
I don't need to put test in front of it, do it?
No, it's test. Go look in test LED, and
Oh,
it's
that's right. That's right. There's a macro there.
yeah.
There's a form. Yep. Like that.
Yeah. And right away I can see we need a mock. We need to mock the listen function.
So we're gonna call loop though, right?
Yeah.
And
Do you remember how to create a mock?
I remember vaguely. I'm gonna do the
Okay, yeah.
thing and look and see how it's.
That's reasonable. It's not hard, it's just kind of you got to get used to it, you know.
Yeah. So it's gonna be one of these.
Yep.
And so returning a, is it called listen?
It's called listen. And I went and closed it, but I think it returns an unsigned 8-bit integer.
So are you UN8ing those?
Yeah. UN8T.
Hardware, there it is. So it returns UN8T. It's called listen and it doesn't return anything. All right.
Got some noise there on line 9.
Okay.
All right, and we've in the setup we've got to do that reset fake function. Test LED setups shows how to do it.
We need to give that a alternate name, or is it?
No, it's fine.
All right. We need to give that a value to return, which I think I saw a way to do that over here.
Yeah. Yep. Function underscore fake dot return value equals. And I think at this point in the test, do we care? We don't really care. We're just caring that it calls it at all, right?
Will it have some default value that it'll return if it does the right thing?
It doesn't. It's going to return whatever comes off the ADC, ADCH register.
Okay.
So there's no default. It will do a reading.
Oh, I got you. Yep.
Oh. Oh. I see what you're saying. The fake itself will return a 0.
Okay.
That's
and we don't care, and that's fine.
yeah. I was thinking you're talking about the actual listen function, which yeah, working on this, there is no ADCH register. Don't forget, you got to put that function down in the loop, or in the group runner. If you just take the function signature up, the test signature up above, and put run in case before and after the word test.
An awesome shortcut.
Oh, case goes after the word test. Sorry. Yep, semicolon at the end to make it happy, and
I've got that.
all right, go ahead and save that. And then you can.
Command S, is it doing anything? Or
It did its thing.
why do I have these red squiggles here?
Where are your red squiggles?
On line 25 and 26.
They aren't here, so they just haven't updated at your end.
Okay, I think it's just leftovers then.
Yep.
Alrighty.
Go ahead and let's run that test. Look at that. We failed.
Sweet.
All right, I'll go implement that then.
Alrighty. I switched to following you. Does that switch our viewers to following you too?
No, they only care about what's going on my end, but that may be switched to follow. It made them switch to following me. Host gets to control that. All right, I think that'll make it pass. It did not make that pass. Well, that's not happy at all. All right, loop should call lightning will fail expected. Huh.
So when you call listen like that, does our fake get called, or do we have to do something to make?
It should be calling our fake. But boy, hardware.h is right there, which is fine. There isn't really a problem with hardware.h being there. What might be over here? I'm worried that there's another listen running around out there somewhere.
Yeah, that was
Another fake listen function.
So how do we know which listen loop is going to be called?
Test LED would be my concern here. Nope, there are no other listen functions in here. Huh.
So we created
Oh,
a fake
oh,
value
oh,
function
oh,
in
oh.
line 8.
Here's what happened.
Okay.
The test that was failing is a different test.
Oh, cool. Oh yeah, we broke something because we changed something, didn't we?
Yep.
You used to call something. You used to call something else in there.
Yeah, line 81, and we shouldn't be testing that there. I'm just going to take that test out.
What was it testing?
This was just seeing that we called lightning when we ran loop.
Oh, that's not valid anymore. So
Yeah. We don't always want to call lightning when we're running loop. So I think that was a test that Lily and I put in just so we could test the LED.
Yeah, to bootstrap the other stuff. Yep.
There. Take that test out of here. Yeah, just because test first is so ingrained in me that I test drive my spikes. All right, it's passing now. Now I'm suspicious.
How can we confirm that it's passing for the right reasons?
Exactly. So I'm going to comment this out.
Okay.
And that should fail now. Okay. It's failing for the right reasons.
Sweet. Did a pairing interview with a candidate yesterday, and one of the questions that came up was just that about removing tests. When was it safe to modify and remove tests? And we had a good conversation about making sure that they were failing for the reasons you expected them to be failing, and only remove them after that.
Yep. Yeah, never trust a passing test unless you've seen it fail first.
And never just delete tests that are failing because you think they should have failed. You need to really confirm that they're failing for the right reasons.
Yes. All right, I want to hypothesize. So this needs to really kind of be of a state machine. So I want to say that we've got two state management functions. One of them is we're doing the lightning loop, and the other one is we're doing the listening loop. And I want to think about what that looks like inside of Stormlight. So right now, we're pretty cruding here. We have a lightning on and a lightning off. And we have this lightning implementation. That feels like a thing that we actually don't need right now. Yeah, these just turn LED on and off, and those are fine.
So we'll probably end up going to some interesting behavior in a state machine, but is there simple behavior we can get to in our loop?
Yeah, that's kind of what I'm
Get us
thinking.
a step closer?
I wonder if we could just have a global state variable and we could check that for right now. Does that seem like a reasonable thing? There might be something better here we could do.
So is like the simplest thing that we could have loop do is if listen return some whatever your threshold was, flash the lightning and move on.
Yeah, just do like a quick flash one, maybe. Yeah, we've got this lightning we've got a lightning function. Oh, you know what? I was about to rip this mock out. This here is just for dependency injection on a mock. This is the prime opportunity to do it, though. So let me go back and look at. Yeah, the void function takes nothing. Then we can put whatever complicated behavior we want in here in the implementation later. But for right now, of lightning mock. And we're going to reset lightning mock. We're going to try typing the name correctly, just for the sheer joy of it. Okay, and we assign our mock to the lightning function. Well, it seems grumbly about that. Why is it grumbly? Lightning mock is undefined. Oh, that'll go better up there. And our ugly squiggles go away. Okay, so the lightning mock has been assigned. And now for fun, I'll try typing in the right place. I was looking at your cursor and thinking it was mine.
Move mine out of the way.
Okay, so main loop should call lightning when listen returns above volume threshold. And I want to define a constant for the volume threshold, and I'm just going to go put that in stormlight.h right now. Usually Wildcard defines up at the top. So this is an unsigned 8-bit integer, so let's just put it halfway up its available range. So volume threshold is 127. I'm thinking in a future version we could make this more sophisticated, like there's a sensitivity dial, but we aren't there right now.
And once you start experimenting with your sensors, you'll know.
Yeah,
You'll be able to
exactly.
what that value actually should be.
So listen fake dot return value equals, we're just going to go to 255 because we know that'll trip it no matter what. Oh, it's return val, isn't it? Okay, yep. Just took a little bit to update. Okay, and then those follow along at home if you haven't seen this pattern before. And by now you probably have, but up here I'm doing my arrange. This is my act. And now here's my assert cycle. And so I want to lightning mock fake call count to be at least 1. Now, that's not what's going to happen right out the gate. That's okay. Oh, now that's really grumbly. Multiple definitions of lightning mock. Okay, so lightning mock is already defined in test LED. I don't need to redefine it here.
Are you able just to reuse it from there?
Yeah. It might cause a compilation error. I have to see. Yeah, we're getting warnings about it doesn't know what that is. Okay, so that's not exactly shocking. So fortunately, this is an easily solved problem.
Can we just give it a different name for now? Or is there a place to put our mocks that
We'll put our mocks out here in a common place. And we need 2 things here. We also need declarations of them, and we need an implementation of them. So the syntax gets a little weird. Lily and I did this a lot in our last engagement, and so I am going to do just a little bit of research here because I don't remember the syntax for what I'm about to do. So I'm going to switch over to the browser. Go to the FFF website. That is not what I was looking for. mean, I'm sure she's a very lovely lady. I've actually watched that video, and it's kind of funny, to be honest.
Was that a music video?
Yes. And I definitely encourage people who are over the age of 18 and not possessed of sensitive ears to watch it. It is very funny. It is very also not kid friendly. Kids also just won't get the joke. Okay, so user defined function return value sequences, custom return value delegates. All right. There is. Well, this will take us further down. There's something in here. There we go. How do I reuse a fake across multiple test suites? And so, right, we have to put FFF into our thing. But so we have a declare fake value func and a define fake value func. And they've got the identical syntax, but we've separated the declaration and the definition of them. So let's switch back to our code. And include FFF. And declare fake void func. And it's not listen, it's lightning. Lightning mock. And we can just copy this. And over here, I think it's as easy as fff.h. And then this becomes define. I know this will be safe if we just include Stormlight mocks.h. Okay, I don't know, but I'm pretty sure that will be okay. And now over here in test loop, we include Stormlight x.h. And we do the same thing in test LED. Test LED really is a mess. I really need to clean that up. Stormlight mocks.h.
Need to get rid of line 21 then.
Yeah.
Is there anything we need to do with CMake so that it picks up the new C file?
There is. Thank you for catching that. All right. We're in our CMake. We did not get told off, so that's promising. All right, it doesn't like Stormlight mocks.h, no such file, or because I can't spell, and I called it Stormlights. So we're just going to go over here, and we are going to rename it. All right, let's try that again. Okay, that built. Everything passed. Should everything be passing? That seems suspicious. Oh, you know what? I didn't. In test loop, I never added my new function into the runner.
Ah. were talking about earlier about making predictions about what your test should do, and then
Yep.
confirming the prediction.
All right. That one was good. So let's go ahead and I will follow you and you can implement. And give me a new test.
I'm going to close this Stormlight box deleted file here. I think that closes it for you too.
Yeah, in fact, I think it was closed on my end already.
Oh, okay.
There are days where I definitely wish we were using Tmux for this pairing. We're all guaranteed the same view of the screen.
Yeah.
Right about the time I got a copy and paste is where I'm really glad we're not using Tmux.
It was threshold, wasn't it?
Getting a little commentary out in the chatter about those of us with gray in our beards tend to prefer those green screens. He's not wrong. If Lily were here, she can tell you I would frequently do that in the afternoons when live share might get a little dodgy. All right, we have an implementation. So now I need a test.
So what is the next behavior we want to have it to have?
Well, Butch, you did not follow the evil pair there.
What did I miss?
Well, line 27 there, you actually implemented the intent rather than strictly the test.
Oh, did I?
Yes, you did.
Let's talk about that so that people
Yeah.
understand what we're talking about.
Yeah, so if you're not used to an evil pair, what you do is you implement the bare minimum to make the test pass. Now, Butch understood my intent. He knew what I wanted to do, so that's what he did here. But when you do that, you sort of leave... sometimes you get lucky and it's okay, but a lot of times you leave yourself in a position where you miss things. And you miss edge cases, and then it blows up on you in production.
Yes. So, yeah, I was thinking a bit further ahead. So, to strictly make that pass, we would leave listen back the way it was.
Oh, you're right. Yeah, that's even simpler than what I thought. Yeah, so now you got to make a test to make me do the thing.
And it does in fact pass with nothing more than that.
It passed. All right. So before Butch told me the name evil pair, I always just referred to this as the lazy pair partner pattern. And there might have been an expletive in there too.
Yeah, and there was and when maybe you're talking to a new candidate and you don't want to bring the words evil in there, you reinforce that when you're doing your red-green refactor, when you want to do the green part, you want to do the simplest thing that will make the test pass. And you want to stay with your strict adherence to that.
Yeah, be as aggressively simple as you can.
So we want to have a test that will actually I think where I went was, even though we had this test where it didn't do anything, that it didn't actually require it to be above that threshold. So the name lured me into being less rigid than the actual test code needed to be.
Yeah. I think make this one explicit about when it's under the threshold and doesn't. Or I guess I should let you figure out which test you want to write.
I think that's a good one.
There's no value in me writing the exam. And I do like to follow the evil pair pattern when I'm doing solo code.
Their advantage to that is if you get to it rigidly, because um, like you said, you might miss things, and you might also put in code that you don't really need sometimes.
Yeah. Yeah, and that's something you got to maintain.
Yes.
So anybody's looking to read on this subject, oh, you got to put that test into the. Yeah, it's very frustrating when you don't get the earth-shattering kaboom. James Grenning in his book, Test-Driven Development for Embedded C, he talks about a very specific pattern to follow uh, for your evil pair tests. And he doesn't call it the evil pair, but it's a zombies pattern. I don't remember what it stands for, but if you're looking to,
01 mini.
yeah,
01 mini
boundaries, exceptions.
boundaries.
There's more, but I don't remember it.
I forget what the I stands for.
Yeah. In any event, I strongly encourage you to read that book if you like to do embedded programming. You want to get better at testing. Just in general, doing the testing feels like more work, but it saves you work pretty quickly. All right, so I have a failing test.
Invalid in edge cases or something like that.
Yeah, that's it. Invalid and edge. Well, one of them is exception.
Yeah.
Okay, when listen returns below volume threshold. Expected 0 got 1. Okay, so that's pretty simple. And this is definitely evil parish here too. But oh dang. I need to go back and look at the test. I thought I had that one. Oh, I think I just did it wrong. No. All right. So listen. Up here, listens returning 255. Oh, yes, I did it exactly backwards. And this is why we test, because we'd like to think we understand logic, but I have literally been tripped up by Boolean values before. It was a very, very dark time in my life. Okay, that passes, and so I'm going to force a boundary value check. So we've kind of left it undefined about what to do about that boundary value.
Yeah.
What do we call that? Volume threshold. Anybody out there who's listening, if you've got questions, go ahead and throw them in the chat. We're happy to answer them. We aren't doing this to write production code. We aren't exactly in crunch mode here. Okay, and I'm asserting that it does call when we are at the boundary value.
Test runner.
Oh, thank you. I was yet again missing my earth-shattering kaboom. Oh, two things. I didn't set the value right. There we go. Okay, so There we go. Now it's failing properly. Oh, let me follow you, and this will go better for the remote viewer.
So
So when it's equal to the threshold, and when it's at a value higher than the threshold, it should call lightning.
oops, didn't get enough there.
Curious what you're up to now. You're going full evil pair.
What it is, it's,
You realize to get the correct behavior, you're the one who's got to write the hard test, right?
it makes it fun, right?
Yeah, it should be you and 8T.
18, okay.
So you did this one to yourself.
I know, but it's okay. Alrighty, so how can I force you to actually do the right thing now?
This feels like a really great opportunity for a loop. You could either actually hit every value, which might get tedious since there's 127 of them, or you could just make it really a pain in the backside for me to have to call out each value.
well, I think my inclination here is to not really go full loopish, but
Yeah, this is fair, and this is the sort of test Lily and I were writing all the time too. When we were doing characterization tests on a legacy rescue project, and that's definitely so. Legacy rescue is definitely a thing we could talk about in here if we wanted to. That pace didn't go exactly as you wanted it, Butch.
it did not. I'm gonna try again.
There a semicolon at the end of that?
There is on my end.
Okay. Well, if it's on your end, it's on my end too, probably. That's better. Yeah. All right. Just because at this point I'm gonna.
I have one of two expectations of what you'll do here, so I want to see what you do.
I could continue the evil pair. I could throw a switch statement in there, which I thought maybe was something you were gonna do. But
Well,
I could.
that's where it leads us, is that we can write either another if or a switch in here, and then in our refactor step saying, now it's gotten complicated. How can we simplify this code too?
Yeah. So I'm gonna inline this since we aren't using that anywhere else. We definitely aren't right now. Maybe some later point we'll come back and say, "Wow, that would have been great to have that."
Yeah.
All right, that might actually be enough to make the light work.
Sweet.
Okay, tests are still good, so that's good. probably if we had the full circuit, we could hook it up and it would work to some degree of satisfaction. I'd like our lightning loop to, or our lightning cycle to be a little more sophisticated than it is. Right now, all it does is it turns on, leaves it on for a set period of time, and then it turns it off and holds it off for a set period of time, and then it returns. And I feel like,
So how would you, in just prose description, describe the behavior that you want it to have?
yeah, I think the behavior I'd like it to have is I want a little variability. I want it more than one flash on. I want several flashes. And I kind of want it to be like regular lightning where I can't really predict it. It's not just going to be 3 flashes every time.
Right.
Maybe make it somewhere between 1 or 2 and say maybe 8 to 10 somewhere at the outside. So
some amount of randomization.
yeah. And since I get to write the next test, I think I'm going to do that. So that's our loop unit. And I feel like
Solve the rest of this behavior in lightning itself.
yeah, I want to kind of make another test unit just to keep things cleaner. Yeah, let's make another test suite just for that, and I want to make sure we clean up after ourselves, and I want to in test LED. I want to make sure we did that as well.
We did.
Oh, geez, there's a whole thing in here just about testing lightning. Okay. I'm kind of the mindset that maybe we just keep that, but I really want this out in its own channel, or in its own, not channel, but own file. I think this file it's got too much going on. So I'm going to add a test lightning.
Note that we have 6 minutes left on our hour.
So we do. All right. Okay. Let's abandon that for right now. We're just going to write another test in here. And test lightning. You can do that refactor offline. It's not that exciting. It's copying a bunch of stuff into another file. Lightning calls. LED on and LED off. A random number of times. And I need to think about that a little bit. That's a really generic thing right now.
So is that the test at line 131?
That is a different test. Oh. I see what you're saying there. Yeah, it really should just be in that test, shouldn't it?
So what would now? Yeah, I was going to ask what would be different if behavior that this test would be testing. That was the length of the on and off. Looks like what it's testing, and you were describing the number of times it would go on and off.
Yeah.
Is that?
This is like one lightning flash.
Yeah. Okay.
And maybe we should extract that instead of just a lightning function. Let's make a lightning flash function.
Okay. be a test that says we need a lightning flash function that we need to write first?
There would. I am just trying to keep the compiler moderately happy. I'm trying to fail for logic reasons rather than.
Right.
Rather than compiler reasons. While that is a perfectly valid test.
It's one of those things that once you have done them enough times to failing because the compiler failed, then you can, you're going to need it, and you might skip that kind of test and get right to it. But you still have to be careful that you're not adding functions
Yeah.
that
Right.
you think you might need in the future.
Right now,
Really,
right now I'm at a refactor. In fact, is what I want to call this. And maybe this is thin ice I'm skating on here. But I had green tests. I still have green tests.
Okay.
All right. Having done that, I want to change this test. So instead of calling lightning, it's calling lightning flash.
Yes.
And we'll have to mock a thing later, but I don't have to mock it right now.
Change the name in the runner. Then.
Oh, thank you. Oh, there's some mocks up there, maybe. Nope, those mocks are all good. All right. We're still good there. And now I want to test about lightning calls, lightning flash, random number of times. And as I'm thinking about this, I quite obviously need a lightning flash mock. I guess I don't right now. I have the LED on and LED off mocks. Counting those, it's delicate.
Yeah, it would be simpler with lightning flash mock there.
Yeah. All right. So I'm going to go enable that kind of thing. So this is my dependency injection happening here. All right, we're very good there. Now back here and test LED. Oh, and that last test needs to call lightning flash impul, not lightning flash. Actually, it doesn't.
No, your test should all pass now, right?
Well, that's a really good and insightful question to ask there, Butch.
Because really all you did was refactor to use it.
Yeah.
The injection.
All right. We've got a clean build, so we know we didn't have something lingering, giving us a false sense of positivity. All right. I don't think I need this anywhere else, so I'm going to put it just in here. Void func lightning flash mock. And we'll reset it down here. And for fun, we'll try spelling things correctly. Okay. And I'm not going to assign it in most cases, but I am going to assign it in this case. Oh, let me check. Let me check a thing. I feel like... Yeah. These are actually calling lightning flash impl. I was about to break the bejesus out of a bunch of tests.
One of those you had call impl, and one of them you didn't.
Oh, thank you. Oh, by default, yeah, they should all call impl anyway, just to be safe. By default, lightning flash is the impl.
Right.
But it would be really easy for me to do the wrong thing right here. So, part of our range is setting up the mock, setting up lightning flash to use the mock, because we're actually going to call lightning. But we have other things up here to do too. So, rand fake dot return val equals. Let's make it equal to 10. Now we can see that lightning flash was called 10 times. Afraid of that. Strip that out.
We need to reset the.
Oh, the lightning flash mock, you're right. Oh, but also cleaning up, yes.
Yeah, this is.
Okay, this is grumbly about something or other. Lightning flash mock fake is undefined. Well, I feel like I did something goofy up here. Lightning flash mock is defined there. Am I resetting it down here? I am resetting it there. What's that? Well, there's the root of my problem.
What is that?
I think this is a case of I got to type in thinking one cursor was a different cursor.
Oh.
There we go. That's a little happier. Test assert equals double. That's dangerous. All right, we were short an N. That was the root of my problem. All right, now let's put this into my... We are coming up about on time, but let's figure we can get this one done. In the background, my fish is getting antsy in his bowl. Or in his tank. Undefined reference. Alright, this is on... Well, that's still grumbly. Oh, geez. Well, this is a fascinating problem.
It really acts like that function's not defined.
Oh, this is a function I did higher up. This is lightning makes lightning for different rand time. It's lightning flash. I got all ambitious about changing stuff up there. All right, lightning calls, lightning flash, random number of times. Okay. I will let you go implement that. And I'll be a good host and follow you so that we can see what's going on.
So right now, lightning nipple just calls lightning flash one time. And I could do the evil thing.
I think the evil thing's the right thing to do here because we're going to have to walk away. So leaving this thing in a questionable state's not terrible. Or there is the alternative option. We leave a broken test.
Yeah, that was. And I could go either way here.
Yeah. It might be a good case for leaving a broken test.
Right.
And so we've got a broken test. It's still broken. All right. Let's... oh boy, we've been busy little beavers here. There we go. So we're just going to do this on the command line because I'm old and stubborn.
I go back and forth, you know.
Yep.
So you know some of those didn't get added, right?
There we go. Everything's good now.
There we go.
There's that git commit AM. And Lily's not here, so I'm not going to make her twitch too hard. She's not wrong about the danger inherent there. All right, that's pushed. Anybody wants to go look at it in its current state is welcome to go do that. And I think we'll call that a week.